Welcome back to the classroom, everyone. Before we dive into today's lesson, please make sure to smash that like button, subscribe to the channel, and follow the account so you never miss an update on our A Plus Masterclass. Today, we are tackling CompTIA A Plus Objective 3.7, Deploying Multifunction Devices. We are going to walk through a chronological guide to MFD configuration, security, and networking. Let's get to work. Professionals think in workflows, and deploying a modern MFD, which converges printing, scanning, copying, and faxing, requires a systematic approach. We are going to follow a strict 7-step lifecycle, starting with the foundation, making the connection, speaking the language of print, shaping the output, serving the masses, locking it down, and finally, managing the input function. Phase 1 is physical placement because unboxing is more than just removing cardboard. The physical location dictates the lifespan of the device. You must avoid areas with excessive humidity, temperature fluctuations, or dust, as poor environments degrade consumables and cause paper jams. Ensure proper ventilation to prevent overheating. From an accessibility standpoint, position the device based on its power requirements, whether that is 110 to 120 volts or 220 to 240 volts, and its proximity to network drops. Always ensure users can actually reach the media guides and trays without obstruction. Next, we establish the brain of the device with firmware updates. Before connecting to the broader network, you must establish its core operating system, reflashing or updating the firmware patches, security vulnerabilities, and adds hardware compatibility. You access this via the physical control panel or a web-based utility using the device's IP address. Best practice dictates you always back up existing configurations first and test the new firmware on a single device before a fleet-wide deployment. And a massive warning, never interrupt a firmware update, as it can corrupt the flash memory and completely render the device unusable. Phase 2 is the wired backbone. Once physically placed, we have to connect the hardware. For a local, single-user setup, we use USB, connecting a Type-B plug on the printer to a Type-A or Type-C port on the computer. The OS typically detects this automatically via plug-and-play. For an enterprise or multi-user setup, we use Ethernet with an RJ45 cable connected to a switch. This requires assigning an IP address or a fully qualified domain name and ensuring the printer can communicate over the necessary TCP and UDP ports without being blocked by firewalls. Moving into the wireless frontier, modern MFDs utilize Wi-Fi and Bluetooth to support mobile and untethered workforces. In infrastructure mode, the printer connects directly to a corporate Wi-Fi access point, making it available via an IP address to all clients, provided it supports the AP's 802.11 standard. Wi-Fi Direct, or ad hoc mode, turns the printer itself into a software-implemented access point, allowing clients to connect directly without a central router. For mobile printing, deployments utilize Bluetooth pairing, Apple AirPrint, Mopria, or cloud-based solutions like HP ePrint. Phase 3 brings us to the language of print, or drivers. The computer and printer speak different languages, so a print driver translates software commands into a raster file, which is a dot-by-dot description of ink placement. While Windows Plug and Play often detects and installs a basic driver automatically, specific configurations require manual installation. You download the vendor driver, use the Add Printer wizard, select Have Disk, and point to the extracted driver folder to choose the appropriate page description language, or PDL. So, let's look at the PDL showdown. PCL versus PostScript. PCL, or Printer Command Language, is designed for speed and efficiency. It is the standard choice for general office settings, churning out large volumes of text documents and everyday data. PostScript, on the other hand, is the graphic designer's choice. It supports advanced vector graphics, highly accurate CMYK color printing, and ensures superior what you see is what you get, or YSI-WIG consistency across different devices. Phase 4 is shaping the output. Using the Windows Printer Properties dialog, we manage settings for hardware components. Modern MFDs have multiple trays for different media. You must configure the driver to assign specific sizes like A4 or letter, and types like cardstock or labels to specific trays to prevent misfeeds. You also define the default page layout orientation, choosing between vertical portrait or horizontal landscape. Next, we use the Printing Preferences dialog to set default print job options for our users. Enabling the duplex unit allows automatic double-sided printing, which significantly reduces paper waste. If the printer lacks this hardware, manual duplexing will prompt the user to reload the paper. For quality, you can adjust the output resolution. Settings like Econo mode save toner for internal documents, while high gloss or high DPI settings are kept for final client presentations. Phase 5 is serving the masses. A single USB-connected printer can be scaled to serve a whole department. In Windows, you navigate to the Sharing tab in the Printer Properties to share the device over the network. Ordinary users with permissions can browse network resources via File Explorer, right-click the hosted printer, and simply select Connect. You can even configure the share to render print jobs on the client computers, preventing the host machine from getting overwhelmed. For massive enterprise scaling, we deploy dedicated print servers. These provide centralized queue management and driver deployment. Administrators load the drivers onto the server so clients automatically download them when connecting. Remember the difference between driver types. Legacy. Type 3 drivers require the server to host both 32-bit and 64-bit versions, but Windows 10 introduced Type 4 print class drivers, creating a framework where a single generic driver works across multiple devices, massively reducing server overhead. Phase 6 is locking it down. An MFD is a full computer with a hard drive, making it a major security vulnerability if left unprotected. The first layer of defense is physical access control. User authentication requires a PIN or network credentials directly on the control panel before accessing functions. Even better, many enterprise MFDs integrate RFID or NFC card readers for badging. Employees just tap their corporate ID to unlock the device, streamlining access while keeping security strict. To protect data privacy, we use secured prints. Imagine an HR rep printing a highly confidential payroll document, but getting distracted by a phone call, leaving the document sitting on a public tray. Secured print solves this. When selected, the job is sent to the print server or MFD memory and held in a paused state. It will not physically print until that exact user walks up and authenticates with their PIN or badge, completely eliminating the risk of interception. To maintain accountability, administrators rely on audit logs to track the who, what, and when. A print server, or the MFD, logs every job, creating a forensic record of documents printed, copied, or scanned by specific users and devices. This is critical for tracking down missing documents or investigating unauthorized information releases. These logs are often transmitted to a centralized monitoring server using tools like syslog. Phase 7 flips the workflow to the input function, digitizing documents. Flatbed scanners utilize a glass surface, making them ideal for high-resolution image capture, fragile items, or thick books that can't feed through rollers. The automatic document feeder, or ADF, is a mechanical tray that pulls pages one by one, essential for high-speed scanning of multi-page text documents. We can also use optical character recognition, or OCR, software to convert these scanned images into editable digital text. Once digitized, we have to route the data using network scan services. Scan to email uses an SMTP server configuration to send the scanned PDF directly to an employee's inbox. Scan to SMB sends files to a shared Windows Network folder using the server message block protocol. Finally, Scan to Cloud uses direct API integrations to push documents to off-site cloud storage like OneDrive, Google Drive, or SharePoint for immediate collaboration. To wrap things up and deploy with confidence, mastering Objective 3.7 means understanding this entire hardware and software workflow. You build the foundation, establish connections, translate with PDLs, configure settings, share access, enforce security, and digitize inputs. To really lock this knowledge in, make sure to finish your study session today by getting some hands-on practice with PBQ-like questions at XP Boost. The link is right down in the YouTube video description. Thanks for watching, and I'll see you in the next one.